You want to talk about a gear shift. We go from dealing with angles and rays and things of that nature to coordinate planes. The very first day was over conditional statements. And now we see we're talking about probability in the realm of something called theoretical and experimental. So this first chapter really is an introduction to the basics of pretty much almost everything we're going to see in geometry this year as far as shapes, angles, probability. It's got a little bit of everything, and I think it's a really good crash course to kind of get you ready for what we're going to see a little bit later on. But I didn't want to rush through this day on probability, so I want to split this into two parts. So today is day 9, part 1. I think you guys will like that too because it'll make these videos a little bit shorter also. And I think it's worth spending a couple days on, not just rushing through all of this probability lesson in one day. And so today, we're really going to focus on this first standard, experimental and theoretical probabilities. Those are going to be our two key words today, experimental and theoretical. And if you think about those and you think, wait, that sounds scientific, that's because it is. These properties come from science. So let's look at a little bit of an example of experimental. So assume we roll a standard number cube. You guys may call it a die. It's got 6 sides, right? So a dice has 6 sides. And what do we call those 6 sides? Well, they are 1, 2, 3, 4, 5, and 6. Now, these 6 options are the only options we could get if we roll a die. This is what's going to be called our sample space. Your sample space are all the possible outcomes you can have whenever you conduct an experiment, whenever you're dealing with probability. It is all the possible outcomes. So we're going to roll this die, this number cube, 8 times. And during this experiment, we end up getting 5, 1, 2, 4, 6, 3, 5, 5. Now, what I want you guys to do, I want you to read over number 1 here. Find P. Now, that is the probability. So if you're wondering what that P is, that stands for probability of rolling a 5. Now, this is based off the experimental probability. We know that the chances of rolling a 5 are 1 out of 6. 5 is only one side of a 6-sided die. But in this experiment, I want you guys to fill in these blanks here and then see if you can give me the fraction that would go with it. Let's see if you guys got this. We rolled a 5 3 times, the first roll and the last 2 rolls, out of 8 total rolls. So our experimental probability, in this experiment, your chances of getting a 5 are 3 out of 8. So that is the experimental probability. It's obviously not the same as the normal probability. Or what we're going to learn is called theoretical. Try number 2 for me, and then see if you feel good about number 3. Let's see if we can label what our probabilities would be experimentally if we're dealing with these results up at the top. Okay, so the probability of rolling is 6. Well, in this experiment, we only rolled it 1 time. So that's 1 out of 8. These odds are actually worse than they are normally if you roll a die, because normally you have at least a 1 in 6 chance of rolling a 6, because 6 is one of the 6 sides. Now, where it gets interesting is whenever you start adding in multiple options we're good with. What would be the probability of rolling an even number based off our results in this experiment? That means rolling a 2, a 4, or a 6. Well, I see 1, 2, 1, 4, and 1, 6. That would be 3 results out of the 8 rolls. How about you guys tell me, what are you thinking for odd? If 3 out of 8 are even, how about the probability of an odd number in this experiment? Well, some of you guys can do the math without even looking up there. If 3 out of 8 results are even, that's got to mean the other 5 results would be odd. 1, 3, and 5. I'm going to give you guys a second here to look at number 4 and read over it. Take a note of what's the experimental probability of rolling a multiple of 3. So remember that word multiple. That means 3 or any number it multiplies into. So that would be 3 and 6. Now that also could be 9, 12, 15, but we know when we get to a certain point that's not happening. So check this out. If you were to roll a number cube 60 times, 60 rolls of a number cube, predict the number of rolls that will result in a multiple of 3. So remember, experimental probability, we're still dealing with these experimental results we got up here, this sample space. So let's think about it. We rolled 8 times up there. What was the outcomes that were a multiple of 3? That's either 3 or 6. How many of those 8 results were a multiple of 3? Well, we got 1 6 and we got 1 3. And that's it. So 2 out of 8, which you guys know reduces down to 1/4. Now that's the experimental probability of these 8 rolls. How can we predict the experimental probability for 60 rolls? Well, we can take the ratio we got for this experiment and let's apply it to 60 rolls. So now we're going to bust out what we call a prediction. We're going to say, okay, those odds, 1/4, we're going to multiply our 60 rolls by that, because with each roll through our experiment, we know that's our odds of rolling a multiple of 3. So you take 1/4 of 60, hypothetically speaking, 15 times we should get a multiple of 3. So if you were to roll this die based off this experiment 60 times, hypothetically you should get 15 of either 3 or 6 combined. Interesting. Now what I'm going to need you to do, I'm going to need you to grab a die. I know some of y'all got Monopoly. We got to have board games laying around. And I want you guys to go ahead and grab this. I'm going to do it too. I've got my die right here. And I'm going to roll this thing 10 times. And I want you to do it too. And what that's going to mean is that's going to mean your answers for 1 through 6 may be different than mine. Because, in fact, they will be. Because there's no way we're going to roll the same results here. If we do, we both need to play the lottery because that's just freaky. So let me go ahead and roll. And you guys can roll with me. All right, I got 1, 5, 2, 2, 4, 4 again, 4 again. Let me throw with my other hand. 5, and we haven't gotten 3 or 6 at all. 2, and last roll. What do you guys think it's going to be? It's going to be me knocking over all my stuff. 1. Man, no 3 or 6. So now, this is an experimental probability. So I know you guys are thinking, wait a minute. Does this mean what I think it's going to mean? For my experiment and for your experiment, you're going to use your results, regardless of whether a certain side showed up or not. So check it out. My probability of rolling a 4, gosh, 4 showed up 3 times. That means I've got a 3 out of 10 chance of rolling a 4. How about rolling a 2? That showed up 3 times as well. Rolling an odd number. Well, 1, 2, 3, 4. 4 out of 10, which would reduce down to 2 out of 5. And here's where things start getting wonky. Rolling a multiple of 3, that would be either 3 or 6. I didn't roll either of those. So based off my experiment, I have a 0 out of 10 chance, or just straight up 0 chance of rolling a 3 or a 6, based off my experiment. How about the probability? How about the probability of not rolling a 1? So literally anything other than a 1. Well, those are going to be pretty good odds for me. I only got 1 twice. So 8 out of 10 rolls, or 4 out of 5, are going to be anything that's not 1, based off my experiment. And rolling a 7, wait a minute, a 7? That's not possible with 1 die. Just like a multiple of 3, this is going to be 0 out of 10, except for in this case, it's because it was literally impossible, not because it just happened not to happen. So that is experimental probability. That's always a fun one because you get to actually do experiments. Hopefully you got some more even results than mine. And here's where we're going to end today, guys. We're going to end by mentioning the other kind of probability. We got theoretical probability. Some of you guys can probably already start to piece together what the difference is going to be here. Theoretical is how we calculate probability based on what we think will happen, not based on any results of what actually has happened in an experiment. So, for example, when we talked earlier about our chances of rolling a die and getting a 3, you probably thought, okay, there's a 1 in 6 chance because 3 shows up 1 time. And you're right. You just gave me the theoretical probability. So rolling a 2 on a die, that's going to be a 1 in 6 chance. That's theoretical probability. Let's take a look here. How about all probabilities of individual events, when we're talking basic rules of probability? They have to fall somewhere between 0 and 1. And what that means is any kind of probability you have for an event, it has to either have a 0% chance, a 100% chance of happening, or somewhere in between. There's no such thing as a negative % chance of something happening. There's no such thing as a 120% chance of something happening. It's got to fall somewhere in this spectrum right here. So, for example, if you are trying to roll a 2, or a multiple, or a 6, or a multiple of 3, these are all events that have at least maybe a 0% chance, but most likely, theoretically, they're going to have somewhere between a 0 and a 100% chance of happening. You sometimes will see this written as 0, and the probability of an event happening has to be greater than or equal to 0, but less than or equal to 100. Now, the probability of an entire sample space, well, your sample space are all the possible events that could happen. So the probability of your sample space occurring is 1, or we're talking 100%, because your sample space is every possible outcome. So, for example, rolling a number cube, the probability of getting something in your sample space is everything. You're guaranteed to get a 1, 2, 3, 4, 5, or 6. There's a 100% chance. Now, there's something called a complement. This is where things can get a little tricky. This is the probability of something not happening. So, for example, maybe the probability that we don't roll a 1, kind of like what we did on number 5 on the previous page. We represent this with a P and a lowercase c. This is your complement. And the way we can find that is by taking 1, 100%, and subtracting the probability of a certain event occurring. So let's say there's a 30% chance an event could happen. You subtract that from 1, you're left with 70% of the complement, aka there's a 70% chance that's not going to happen. And so theoretically, guys, I'm going to let you practice. Let's say we're rolling a standard number cube. Theoretically, what are our chances individually of these 4 things happening? Remember, it's going to be out of 6 because there's 6 possible events in our sample space. Go ahead. Okay, check out what I did here, guys. I said that when we roll a 5, 5 is the outcome we're looking for. That's a 1 event outcome. So 1 out of 6. But then you get to these others, rolling an even number. Well, 2, 4, and 6 all meet that category. That's 3 out of the 6 options. We know that reduces down to 1/2. Similar thing for number 3. Probability of rolling a multiple of 3, that's 3 and 6. Well, that's 2 options out of 6, which reduces down to 1/3. Finally, the probability of not rolling a 1 or 2, aka the probability of rolling the complement of 1 or 2, is going to be 4 out of 6, 3, 4, 5, and 6, which reduces down to 2 out of 3. Now, I've thrown a lot at you as far as probability is concerned. We've talked about what probability is. We've talked about experimental probability, what a sample space is, theoretical probability, and the complement. These are a lot of different concepts here. And so before we dig into how these apply and differ from each other, I wanted to kind of stop. What I would really encourage you guys to do is go to our Chapter 1 resources and look for the homework for day 9. And if you want some practice, I would really encourage you guys to try some of that because the answers are in the back of that document. So you can always check your own work. But be ready because we're going to dig into the weeds a little bit more on Monday. And we're going to make sure you guys feel really comfortable with probability because who knows, you might even see one of those as one of the major questions on your test next week. But if you have any questions, guys, you know you can contact me through email, reminds, the Google Meet during school, just anytime, guys. I'm here to help. I'll try to get back to you as fast as I can. And we've only got one day left after day 9, so be ready and let's finish strong.